Hello and welcome back to this channel. Dear students, today's topic is series ACRL circuit. This is the topic from the subject basic electrical engineering for first year engineering students. Dear students, I have already created one video related to AC signals, that is purely resistive, inductive and capacitive circuits. If you haven't yet watched that video, do watch it. I will provide the link in the description box. So without wasting the time, let us start the topic. As the name indicates, it is series RL, resistor inductor circuit. So diagram is pretty simple. I have drawn one resistor and capacitor in series. Supply voltage is V is equals to Vm sin omega t. VR is voltage across resistor, VL is voltage across inductor. Now, I will tell you simple techniques how to draw the phasor diagram of any circuit. Presently, I will teach you how to draw the phasor diagram of this series RL circuit, and we will also derive the expression for power developed in this circuit, as well as we will solve few numericals. So, as shown in this figure, supply voltage is Vm sin omega t. Now, you should know one important concept, that is the concept of impedance. We know that in case of a resistor, we have the value R. Resistor is the opposition to the flow of current. Similarly, there is one more term which is denoted by X, and X stands for reactance. What is the reactance? If you have inductor or capacitor, then the opposition provided by inductor or capacitor is denoted by term X, which is known as reactance. In this circuit, there is a resistor as well as inductor. So opposition of a resistor is denoted by normal notation R, but opposition of an inductor is denoted by X to the base L. X stands for reactance, L is the reactance of inductance. Now total opposition by resistor as well as inductor is known as impedance, which is denoted by Z, and Z is equals to R plus JXL. This is called as impedance, whose unit is ohms. Now, if you want to calculate magnitude of this impedance, it is represented like this. Mod Z is under root of, use a mathematical formula, very simple formula. Do remember it like this. R is the real part. The term getting multiplied with J, that is XL term, is known as imaginary part. So R is real part, XL is imaginary part. Magnitude of Z is square root of real part square, that is R square, plus imaginary part square, that is XL square. If you want to calculate the angle, then it is denoted by phi, and it is tan inverse of, formula is tan inverse of imaginary part upon real part. As we discussed, imaginary part is XL, real part is R, so it is tan inverse of XL upon R. So this is the concept of impedance which is required for further derivations. Now the next part related to this is, we should be in a position to draw the phasor diagram. How to do it? Do remember it like this. In case of a resistor, there is no phase shift. So current flowing through the resistor and voltage across resistor are along the same phase. As shown in this diagram, resistor and inductor are in series. Whenever the components are in series, that means they are connected one after other. Same current flows through it. So since the current is same, to draw the phasor diagram, I will take this axis as a reference axis, which is a current axis. Why I have taken current as a reference? Because same amount of current is flowing through both the components, whereas voltage across resistor, VR, is different than the voltage across inductor, that is VL. Voltages are different, but current is same, so I have taken current as a reference. Now, another thing, what I said, in case of a resistor, voltage across resistor and current are along the same phase. They are having the same phase. So, I will mark along the same line the value of voltage, that is VR. It is voltage across resistor. Now, one important concept. In case of inductor, the voltage leads current by an angle 90 degree. Do remember this concept. For inductor, voltage across inductor leads current by an angle 90 degree. So, if I want to draw phasor for inductor, I will draw in a perpendicular direction like this. I will mark this line as VL. This angle is 90 degree. Now, Consider this as VR line, this is VL line, voltage across inductor. If you want to draw resultant of this mathematically, the resultant vector will be like this. This is the resultant voltage V. Let us say this makes an angle phi. So this is the complete phasor diagram for the given series RL circuit. If I want to draw the phasor diagram for impedance, how to do it? You just have to remember one phasor diagram. Before that, we will draw the phasor diagram for voltage only. How to do it? V is the resultant voltage, VL is the voltage across inductor, VR is the voltage across resistor. Now, if I want to draw a separate diagram, then on this axis I will show VR because I am drawing the diagram for voltage only. This axis is VL and this resultant value is V. This axis is VL. Similarly, if I will draw one parallel line over here, that will be again VL. So this is the voltage triangle. It is known as the voltage triangle, which represents the phasor diagram for voltage in case of series RL circuit. Now do remember one basic formula. We know that voltage is equal V is I into R, current into resistance. This is the basic formula. This is the resultant voltage. For resultant voltage, I will write it over here. For resultant voltage, V is equals to I into Z. Why Z? Because it is combination of the two. V is resultant. Basic formula is current into resistance. So in this case, since it is combination of R and L, it is denoted by Z. So V is equals to IZ. VL can be represented as current into, since VL, base is L, it is voltage across inductor, it is current into reactance of inductance. Do remember like this. Resistance is opposition of a resistor. XL is the reactance, that is opposition of a conductor to the flow of current. So it is I into XL. And VR is equals to I into R, normal formula. Now, if you want to draw the phasor diagram for impedance, that is known as the impedance triangle, how to do it? Very simple trick. Divide each side by current. Why? Because from this equation, I can write R is equals to V upon I. That is, resistance is V upon I. On the same lines, I can say impedance is voltage upon current. I have this impedance triangle. This triangle is known as impedance triangle. If I will divide each side by I, then whatever resultant diagram I will get, that will be the diagram for impedance. So diagram will be similar, only notations will be different. So this is now impedance diagram. Notations will be R because I have divided each side by I. This is XL and this line is Z. This is, say, origin in each case. So this is the way how to simply remember the phasor diagrams for this circuit. Now if it is asked to draw the waveforms of voltage as well as current, how to do it? So on this axis, on x-axis, I will mark 0 reference over here. On x-axis, we have to mark current or voltage. On y-axis we have to mark current or voltage. On x-axis we have to mark time period. If I will consider a sinusoidal waveform, to make the analysis simple, always and always consider a sinusoidal waveform. First I will draw the current waveform, ideal current waveform starting from origin like this. Since I have considered a sine wave, it is simple current waveform. I will give the name to this waveform as current waveform, that is I. Now, how to remember the things? There are so many diagrams in the subject, so you should remember each thing logically. What I said, in case of RL circuit, the voltage across inductor leads current by an angle phi. That's what we discussed. This is the diagram of current. I want to draw the diagram for voltage. Since it is leading, that means it will start after some time. After how much amount? After an amount phi, because voltage across inductor is leading by an angle phi than the current. So if I want to draw the diagram of voltage, the starting point is this. Let us say this value is phi if I am measuring from origin. The nature of diagram remains same, that is sinusoidal. Value of voltage is more than that of current. So I have shown amplitude more than that of current. This is the simple way how to draw the diagram of voltage and current. And naturally on this axis I will write V comma I. That is diagram for voltage and current with respect to time. The next important derivation is derivation of power for series RL circuit. We are considering the same diagram what we discussed right now. We have discussed that in case of series RL circuit, the voltage leads current by an angle phi. So I have considered reference equation of a voltage V is equals to Vm sin omega t. Let us say equation 1. Since we discussed voltage is leading than the current by an angle phi, in another language, current lags voltage by an angle phi, one and the same thing. So since I have taken a reference as a reference the equation of voltage, I am writing equation of current as I is equals to on the same lines. Since it is V is equals to Vm sin omega t, for I have written Im sin, but this is the current. What we said, voltage is leading, means in another language, current is lagging, so it is sin omega t minus phi. Do remember like this, lagging means for angle phi there should be minus sign. If it would have been leading, I would have put plus sign over here only. Now, next part is generalized equation of power is V into I. So let us take multiplication of these two terms. So simply I will write it like this, Vm Im sin of omega t into sin of omega t minus phi. Now to simplify this part, I am talking about these two terms. I need to make use of one trigonometric identity which I have already written. It is sin A into sin B is cos A minus B minus cos A plus B upon 2. If you want to apply this identity to these two terms, then A is omega t. In first term we have sin omega t, here we have sin A, and B is omega t minus phi. So let us make use of simple formula. Do remember here in the first term I have cos A minus B. So A minus B can be written as omega t minus of omega t minus phi. This becomes omega t plus phi. Minus of minus becomes plus. This gets cancelled. So A minus B is simply phi. Same way A plus B can be written as omega t plus omega t minus phi, which is 2 omega t minus phi. So let us make use of this identity. It is cos A minus B minus cos A plus B upon 2. I will take 2 outside. So this equation of power can be written as Vm Im upon 2 in the bracket. I have taken this 2 outside the bracket. Cos A minus B. I have generated value of A minus B. It is cos A minus B. So it is cos phi, then minus cos A plus B, that is cos value of A plus B is 2 omega t minus phi, 2 omega t minus phi. This is the equation of power, but this is instantaneous power. Now it has two terms. First term is Vm Im upon 2 into cos phi. Second term is minus Vm Im upon 2 into cos 2 omega t minus phi. So I will write it separately for the simplicity. So first term is Vm Im upon 2 cos phi minus second term Vm Im upon 2 cos of 2 omega t minus phi. If you want to calculate average power, this is the expression of generalized power or instantaneous power. If you want to calculate average power, then simple technique is take the integration of this final equation what we have derived right now. So to calculate average power, I will write the new equation like this. P average is equals to integration of this calculated power. Now I will tell you one simplest thing. If you integrate, this second term contains cosine wave. If you integrate cos term or sine term for one full cycle, answer of integration is 0. So in any subject, whenever you are integrating sine or cosine term for one complete cycle, answer is 0. So I am neglecting this term because I am going to get answer 0. How to remember it? Integration of sine or cosine term for one full cycle is 0. So I am neglecting this term. I have to integrate only this term. So this equation becomes simply integration of Vm Im upon 2 into cos phi. I have to integrate this equation. Now let us solve this integration. This is pretty simple integration because entire term Vm Im upon 2 into cos phi is constant as far as the integration is concerned. So simply I can write P average is Vm Im upon 2 into cos phi. Now in case of average power, you need to express the things in terms of RMS quantities. So this is 2. So I can well write this as Vm upon root 2 into Im upon root 2 cos phi. Very simple logic. This term 2 can be written as root 2 into root 2. So if you take multiplication of root 2 into root 2, it is 2. So I have written it separately. Now V is maximum current, Im is maximum voltage, Im is maximum current. So it is written as V RMS, that is RMS voltage, into I RMS into cos phi. This is the derivation of average power for series RL circuit. Now, as far as power is concerned, there are 3 different types of powers. One is known as apparent power, which is denoted by S, and it is given by V into I. Second type of power is known as reactive power, which is denoted by Q, and it is given by VI sin phi. Third type of power is real power or active power. It is denoted by P, and which is given by VI cos phi. These are the formulae of calculation of different types of powers. Now there is one important term related to this, which is known as power factor. The term power factor is simply denoted by P dot F dot, power factor, which is defined as P upon S. Means theoretically it is ratio of real power to the apparent power. So simply put the values. Value of P is VI cos phi divided by S. Value of S is VI. Therefore power factor is equals to cos phi. This is the equation of power factor for series RL circuit. Now let us solve numerical to get an idea of this derivation and other concepts. Let us discuss one numerical. As far as numerical part is concerned, almost all numericals are of same type. I have made a list of formulae which is required to solve the numericals on this part. V is under root of VR square plus VL square. I current is VR upon R, which is same as VR is voltage across a resistor, R is resistance, which is same as VL. VL is voltage across inductor upon XL, reactance of inductance. Then XL basic formula is 2 pi FL. F is the frequency, L is the value of inductance. Power is given by I square R. Power factor, generalized formula I have written, is cos phi, which is same as P upon VI. Now, the given question is resistance of 5 ohm. So R is equals to 5 ohm is connected across 200 volt. Supply voltage is given as 200 volt, 50 hertz frequency. So F frequency is 50 hertz. 1 phi means single phase supply. Voltage across resistor is 50 volt, that is VR. Voltage across resistance is 50 volt. First part is calculate voltage across inductor. Now do remember this generalized formula. If suppose in another numerical, suppose VL is given and it is asked to calculate VR, same formula is applicable. So I am making use of this formula. First formula, V is under root of VR square plus VL square. My aim is to calculate voltage across inductor. Voltage across inductor is denoted by VL. So I need to calculate VL. So let us simplify this equation. Take square on both sides. If you take square on both sides, then square root gets vanished. So it becomes V square is equals to VR square plus VL square. Therefore, VL square is equals to V square minus VR square. Now V is the supply voltage, VR is the voltage across a resistor, all values are given. Before that, this is equation of VL square, so I can write equation of VL is square root of V square minus VR square. Simply put the values. So it is square root of V is 200. So it is 200 square minus VR, that is 50 square. If you solve this on the calculator, then answer of VL is 193.64 unit is volt. This is the answer of first part, that is voltage across inductor. Second, value of inductance. Now how to calculate value of inductance? We have the formula to calculate current I. I is given as, I am using first formula, I is VR upon R. So VR upon R. All the values are given in the question. R is 5, VR is 50. So it is 50 upon 5, which is equals to 10 ampere. But same formula is applicable for VL upon XL. Therefore, I can write VL upon XL is same as equation of R, value of I. So VL upon XL is equals to 10 ampere. Therefore, XL, I am just rearranging the terms. I will transfer XL over here, 10 at the LHS. So XL can be written as VL upon 10. VL is voltage across inductor, which we already calculated. So it is 193.64 upon 10. So simply 19.364. This is the value of XL. But what is asked in the question? Value of inductance. We have the formula of XL, that is 2 pi FL, where F is the frequency, L is the value of inductance. It is asked to calculate value of inductance. So using this formula, first I will write this formula. XL is 2 pi FL. Therefore, L is equals to XL upon 2 pi F. Value of XL we have calculated. It is 19.364 upon 2 pi into value of F. Value of frequency is 50 Hertz. Solve this on the calculator. So this answer will be 61.64. It is the value of inductance. So its unit is Henrys. So value of inductance is 61.64 Henrys. Third part, calculation of power. We have a ready-made formula. P is equals to I square into R. Therefore, power can be written as P is equals to I square into R. Value of I we have calculated. It is 10 square into R. Value of R is 5. So the answer of power is 500 watt. It is a calculation of power. So its unit is watt. Now last part, calculation of power factor. I have given you the generalized formula. So power factor is also denoted by cos phi, which is given by P upon VI. Therefore, power factor is equals to P upon V into I. Value of P is 500 upon value of V is 200 into current. Value of current is 10 amperes. Therefore, power factor is equals to 0.25. From the exam point of view, always there is a confusion while solving such numericals, whether to write it is leading power factor or lagging power factor. Make the things very simple. What we discussed in the derivation of power, that the current is lagging, voltage is leading, means current is lagging. Always and always try to remember the things with respect to current. Since current is lagging, this power factor is said to be lagging by an amount 0.25. So that's it for this session today. So thank you very much.